assigned?
Practice quiz was assigned. I put it up on Friday. Or sorry, no.
All right.
It's been up there for a while. I didn't touch it yesterday, so it must have been Monday morning I put it up. But it didn't make it available until after Monday. So I wanted you to have that practice quiz in there so that you had an idea what kind of questions I was going to ask you later today. Okay. And I got a few people who have been who haven't listened carefully. I've asked you to turn on your cameras. If your cameras aren't working, you've got a problem because the camera has to be on during the quiz. And I want to see your face now so I can see if you're learning stuff along the way. All right. Well, any other questions? Okay. Now, it's okay to stop to say something in the middle when you, because I can't see you raise your hand because I'm looking at the PowerPoint. So you're going to have to say something to stop me. I won't even know who it is. I'll just hear a voice. Does that make sense? When you don't understand a step, let me know what's going on because I need you to be good at these steps. Okay. Well, without further ado then, let us look at a little bit more on conversion factors, dimensional analysis. So, these were the kinds of questions that were put into you had on the practice sheet. Okay, so let's go back what through the process is and what question, how we should be thinking. So the first thing I do is I write down what they give me. So I just copy down what they give me. Then I make a conversion factor. Okay. Then I make a conversion factor. That conversion factor, I want to, and once I've done this, I say, okay, now what unit do I want to get rid of? I want to get rid of meters, so I need to put meters on the bottom, because that will make it cancel out. What can I turn meters into that will get me closer to millimeters? Well, I can turn millimeter, I can do straight from meters to millimeters. What can I, which is bigger, a meter or a millimeter? Well, a meter's bigger, so it gets the 1, and the smaller unit, the milli, remember mil means 1,000. You get that? So 1,000 millimeters to 1 meter. I multiply that, my calculator gives me 8,300. This has 2 sig figs, and this is a definition, so it's unlimited sig figs. So I should have 2 sig figs in my answer because between 2 and unlimited, 2 is the smaller number. So that would be 8,300 millimeters. That's what I was looking at you doing today. We could have also done it the other way I wanted to do is kids hate doing anything, that's a capital D, during cold mornings. I start off at meters. I want to go to millimeters. I should move my decimal point 1, 2, 3 to the right. And if I take 8.3 and I move the decimal point 1, 2, 3 to the right, I get the same number. So if you stay in the metric system, your sig figs won't change. I start off with 2 sig figs, I end up with 2 sig figs. So, if you had 1.56 trillion, only 15,600,000,000 micrograms, how many kilograms would you have? Oh, that one I'm not doing in my head. I'll need a calculator. So 1.56 times 10 to the 10th micrograms. I copy down what they gave me. Set up my conversion factor. What unit do I want to get rid of? Well, that would be micrograms. What can I turn micrograms into? Well, micrograms has a prefix, so I can get rid of that prefix and turn it into grams. Which is bigger, a microgram or a gram? Well, a gram is bigger, so it gets the 1. And the microgram, micro's is really tiny. So micro means 10 to the 6th. Or you can type a million if you want to. I'm too lazy. And that gets rid of micrograms. But it's not the unit I want. So I set up another conversion factor. What unit do I want to get rid of? Well, now I want to get rid of grams. Where's it got to go? On the bottom. What can I turn grams into? Well, I can turn grams into kilograms because this doesn't have a prefix. I can add that prefix. Which is bigger, a gram or a kilogram? Well, kilogram is bigger, so it gets the 1. And there are 1,000 grams in a kilogram. And that cancels out the grams. So I've got the unit I want. I probably set the problem up correctly. So to push that into my calculator, all I remember is things on top you multiply, things on the bottom you divide. So 1.56 times 10 to the 10th divided by, now to get this 10 to the 6th into my calculator, I'm going to do 1 times 10 to the 6th. Divided by 1 times 10 to the 6th divided by 1,000 equals 15.6 kilograms. Now, I did it on my calculator. I want you right now to take the time to push those buttons on your calculator and see if you can get 15.6. Got a calculator there? Because I got some people that are using their calculators wrong. And I want to make sure you can use them before we rely on them heavily. If you get 1.56, what happens there is people get 1.56 have type 10 EE6. And 10 EE6 is 10 times 10 to the 6th, which is 10 to the 7th. If you got if you got 1.56 times 10 to the 7th, no, not 7th, to the 13th, if you got to the 13th, that means your calculator doesn't think of this as a number, 1 times 10 to the 6th. So to make that your calculator think it's a number, if you got 10 to the 13th, you need to put parentheses when you type in scientific notation. If everybody typed parentheses, it would work fine. But if you got 10 to the 13th, you need parentheses around your 10 to the 6th. And you got to do that every time you divide. In fact, that's the only place it'll cause you problems, is when you're dividing. So if you divide by a scientific notation, put parentheses around it if you got 10 to the 13th. Did anybody get something that wasn't one of the answers I came up with as the things that would go wrong with your calculator? Anybody get something different? So I can show you, because if you can't use your calculator, this is going to be a really long year. But no hands up, no questions. Okay. All right, so there are some numbers that don't have sig figs, which is strange. Okay. do you mean numbers without sig figs? Well, sig figs come because we estimate the last number. We have a last number we're not sure of. And we only want one digit we're not sure of. Because if I'm not sure of something in the tens place, I have no idea what's in the hundreds place, or in the ones place. Okay? So how can you get exactly what you can get is the numbers that you get without measuring. Here's a place you can get numbers without measuring. Counted. So when I go to the grocery store and I buy a dozen eggs, is there any uncertainty in the 2 in a dozen? I mean, if you see a dozen eggs is 12 eggs, that means you're not, and you say that that's got 2 sig figs, you're saying that you're not sure that's a 2. That's really someplace between 11.9 and 12.1. You go to the grocery store. Are you going to buy 12.1 eggs? Or, because that means those eggs are really messy because somebody got an egg all over them. Or, you're going to buy 11.9 eggs? No, you want whole eggs. It's a whole number. So this is really, when you have a counted number, it's really 12.0000000, and those zeros continue forever. So those would all be sig figs because they're all after the decimal point. So that would be unlimited sig figs. How about if there's 32 students in a class? Anybody want to be in a classroom with 31.9 students? I don't. So if the number is counted, it doesn't have an estimate. Okay? The reason why metric has unlimited sig figs is because we're working with definitions. So definitions always have unlimited sig figs. So the reason why the conversion factors for meters and centimeters has a unlimited sig figs because it's exactly 1 meter equals exactly 100 centimeters. There's no estimated number. The definition of a meter is not of a meter is not somewhere near 100. It is 100. It's not 99. It's not 101. The definition is 100. It's got to be exactly 100, and exactly 100 is 100.0000. Those zeros continue forever, and they would all count as sig figs. Outside the metric system, 16 ounces is 1 pound. Why? Well, because that's the definition. So it turns out that if you're in the same system, they're definitions. If they're in the same system, they don't have any estimated numbers. Neither definition nor counted numbers have any numbers that are estimated. So these, we would say, have unlimited sig figs. So these are not going to be what determines the sig figs in your answer. It's going to be something else. Usually, well, actually, a measurement's got to limit your sig figs. That's what limits sig figs, is that they're measurements. Okay, so like we said, so what I just showed you there, that a state metric, it had unlimited sig figs. If it was all English system, pounds and ounces, inches and feet, those are definitions, so they have unlimited sig figs. But if I give you a conversion factor that has meters and feet, 2 different systems, the only way to figure out how many feet there are in a meter is to lay the rulers next to each other. And when I lay the rulers next to each other, I'm measuring. And when I'm measuring, I'm making an estimate. So I will write things like 1 inch is 2.54 centimeters. Okay? So notice how this one, inch, is the stuff we use, the English system. And 2.54 centimeters is metric. So I've got one that's the system we use, inches, another in the metric system. And the only way to get those two together is to put rulers next to each other. Okay? And when I make my conversion factor, it doesn't matter which one. When you look at that and you're doing the math, you say, oh, I am multiplying by 1. That has only 1 sig fig. You say, whoa, 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 whoa. Let's look at what this says. This says that 1 inch is 2.54 centimeters. Can I say 2.54 centimeters is someplace between 0.9 and 1.1 inches? That doesn't do any good. So when I see this conversion factor that has both systems, one is in inches, one is in feet, I take the most that's in there. And the most in there is 3. Okay? So now we have to look at our conversion factors and decide how many sig figs the conversion factor has. And you look for the one that has the most in the conversion factor. My computer made noises it's not supposed to make. Okay, so, sorry, got distracted by somebody coming in. Okay, so we've all heard a 10K race. Okay, a race is 10 kilometers long. How far is this in miles? Now, if we got any track people, they know. They know how long a 10K is. But for everybody else, we're going to find out how long a 10K is. Okay? Now, I will provide you with information. Here's some information. 1 mile is 1,760 yards. Because I don't expect you to know that I don't expect you to know the English system. And a meter is 1.094 yards. So I'm going to start where I always start. And that is writing down what they gave me. 10.0 kilometers. Then I ask the questions I keep asking. What unit do I want to get rid of? Kilometers. Where's it got to go? On the bottom. What can I turn kilometers into? Well, I can't turn kilometers into miles. I don't know that. So I gotta plan a route here. Can I get from kilometers to miles? Well, to get miles, I'll need yards. And to get yards, I'll need meters. Can I get meters? Well, yeah, because I've got kilometers. Kilometers I can turn into meters. And then meters I'll be able to turn into yards. And then yards I'll be able to turn into miles. Okay. So I want to get rid of kilometers. They go on the bottom, change it to meters. Which is bigger? A kilometer is bigger, so it gets the 1. The meter gets the 1,000, because there are 1,000 meters in a kilometer. Got to be the same size. And kilometers have canceled out. Okay. Now, I don't have the unit I want. So what unit do I want to get rid of? Now I want to get rid of meters. Where's it got to go? Well, to cancel out, it has to go on the bottom. Okay? So I'm going to start where I always start. And that is writing down what they gave me. 10.0 kilometers. Where's it got to go? On the bottom. What can I turn kilometers into? Kilometers. Where's it got to go? On the bottom. Okay? So now I don't have the unit I want. So what unit do I want to get rid of? Now I want to get rid of meters. Where's it got to go? Well, to cancel out, it has to go on the bottom. What can I turn meters into? Well, meters I can turn into yards. And now I don't have to worry about which is bigger because they put the numbers right there. The number in front of meters is 1. The number in front of yards is 1.094. I can just copy them down. And my meters have canceled out. Now, what unit do I want to get rid of? Well, that would be yards. Where would it have to go? On the bottom. What can I turn yards into? Yards I can turn into miles. And I put MI for miles because M is meters, so we got to distinguish between those two. So MI for miles. And I don't have to know that, I don't have to think which is bigger because it says 1 mile is 1,760 yards. Okay. So now I've gotten rid of yards. I've got miles, the unit I want. So I just have to push buttons on my calculator. So let me push buttons on my calculator. I'm going to push the 10. The 1,000's on top, so I'm going to push times 1,000. The 1.094 is on top, so I'm going to push times 1.094. And the 1760 is on the bottom, so I'm going to divide by 1760. And if you do all that, my calculator gives me 6.21590 repeating miles. So now I have to think about sig figs. So the 10 kilometer, 10.0 kilometers, that had, I don't know where I jumped to. That 10 kilometers had 3 sig figs. Okay? My first conversion factor. The 1,000 meters is 1 kilometer. Are those the same system or different systems? Well, they're both metric, so they're the same. And if they're in the same system, they have unlimited sig figs. Next one, yards and meters. Same system or different systems? Well, yards is English, the stuff we use. Meters is metric, the stuff the rest of the world uses. So those are different systems. So the rule says that if I got different systems, I pick the most in the conversion factor. 1.094 has 4 sig figs, so that has 4 sig figs. And the last one, miles and yards, same system or different systems? Well, that would be the same system. Okay? So if they're the same system, they have unlimited sig figs. So if I look at those numbers, I did all multiplication division, and there was 3, unlimited, 4, and unlimited. Which of those numbers is smaller? Why, that would be 3. So I need to round this to 3 sig figs. So with the third sig fig being that 1, behind that 1 there's a 5, and I get 6.22 miles. Make sense? So we're not using any new techniques. We're just getting our conversion factors from someplace else. It's not new stuff. We're just using different conversion factors, which means we have to think about sig figs differently. Okay, so everybody okay with that? So notice we did 3 conversion factors. You can string these conversion factors into a long chain of calculations, but it's always, what unit do I want to get rid of? Where's it got to go? What can I turn it into? That'll get me closer to my answer. It's the same process over and over again. All right, so let's look at another one. Pikes Peak is 14,110 feet above sea level. What is that in meters? Okay. Colorado's got a lot of mountains that are just over 14,000 feet. This one you can see as you come across the plains. Oops. I need to give you some information. And the information I'm giving you is the same as the one I gave you on the last one. Okay. So I start off by copying down what they gave me. 14,110 feet. Now, I know that at the end, I want my final answer to be meters. So I need to plan a route between feet and meters. Can I turn feet directly into meters? No, I can't. So what can I turn feet into that will get me closer to meters? Or what? And the other way to look at it is, what can I turn into meters that's up here already? And what I can turn into meters up here is yards. Can I turn? So if I get yards, I can turn it into meters. Can I turn feet into yards? Well, yeah, I can do that. Those are both English ones. Now, you may know the relationship between feet and yards. I hope you do. You should. But if you ask me on a test, Mr. Green, how many feet are there in a yard? I will say 3. Because I don't care if you know the... I'm not supposed to judge whether you can know the English system. You should. But I do need you to know the metric system. If you ask me how many centimeters are in a kilometer, I won't tell you that. Okay, so $14,110 feet. Feet into yards. 3 feet is 1 yard. Notice how I wrote those numbers in so I could see that they were the same size. Because if I wrote 3 yards as 1 feet, I would know. I would say that out loud, and I'd go, "No, that's wrong." Now, what unit do I want to get rid of? Well, I got yards. Where's it got to go? Well, to get rid of it, it's got to go on the bottom. What can I turn yards into? Well, I can turn yards into meters because that's what I wanted. So I get rid of yards. But I need numbers. It says 1.094 yards is 1 meter. So now I got the unit I want. So I probably set the problem up right as long as I copied numbers okay. Now I just have to push buttons. 14,110 feet. The 3's on the bottom, so I push divided by 3. The 1.094 is on the bottom, so I push divided by 1.094. And my calculator gives me calculator gives me 4,299.2078 meters. That's too many digits. So now I need to think about where I should round off for sig figs. So 14,110 feet, that's 4 sig figs. The 0 doesn't count, but the other numbers do. The 1 yard and 3 feet, same system or different systems? Well, that's the same system, so that's exact. That's a definition, so it's unlimited. meters and yards. Well, with meters and yards, they're different systems. So I take the most sig figs in them. So that has 4 sig figs. So I got 4, unlimited, and 4 for my sig figs. What's the smaller number? Well, 4. So I need 4 sig figs in my answer. That second 9 is the 4 sig fig. So 4, 2, 9. Behind that 9, there's a 2. I leave it alone. And I put meters. And hey. So that the problems aren't really that different. You're just using metric instead of you're not doing it all metric. You've got some English pieces in there. Okay,